Hi, welcome to this video where we're going to discuss a topic about taking a mutual induction transformer like the one I have drawn up here and connecting it so that we can turn it into an auto transformer. Now this is a very theoretical topic. It's not something that in my experience is done very often, but the theory behind it is very cool. So we're going to take this mutual induction transformer. I have 4 kVA, 120 volt on the X winding, 480 volt on the H winding, and we're going to say we want to turn it into an auto transformer. Now we know an auto transformer is one big common winding. And I'm going to draw it like this, right? So we are going to take a 120 volt source, like that, connect it still to this, right? This would still be my X winding, right? And we are actually going to connect it to provide us with 600 volts. Now what we have done, essentially, this connection, right, here's my H winding, we've put those two windings in series like this. So we have a 120 volt source, 120 plus that 480 volt H winding is going to give us a 600 volt output. Now, before we get too much more into it, I always like to start with, before we do the math, is the auto transformer. Let's figure out our numbers as the mutual induction transformer. So if this mutual induction transformer, 4 kVA on the X winding, the 120 volt winding, that rated current here would be 33.3 amps. Okay, so if the rating is 33.3 amps on the X winding, my H winding, 4,000 VA divided by 480 volts, my rated current down here would actually be 8.3 amps. So that would be my rated current on both of those. Now, the thing to remember, when I take those windings, and what I'm essentially doing here is I'm taking this winding and putting it in series with that winding, right? Taking my X and my H winding and put them in series. And then I'll be connecting my load, right, from there to there, right, from X1 to H2, I guess, in this point. That's what I'm doing here, and I would measure from there to there, 600 volts. Anyways, the winding ratings don't change, right? My X winding is still rated for 120 volts. My X winding here, still 120 volts. My H winding, still 480 volts. Those ratings don't change. Now, what happened is our X winding became the common winding. My H winding became the series winding. What also didn't change, though, is that current that those windings can handle didn't change. So I still have, on my X winding, I can still have 33.3 amps. On my H winding, I still have 8.3 amps. The rating of those windings doesn't change. Now, that's all really cool, that's fine and dandy, but now when it's an auto transformer, we want to know what is my total ratings. Well, we know in an auto transformer, I can take my apparent power of my transformed VA plus my conducted VA to get my total VA. Now, I do have another video which discusses all of those a little bit more detail. Well, I'll link that up above as well as in the description below to kind of get the basics. But we can figure out on this transformer, what is our S transformed? Well, remember, transformed VA is common voltage times common current. So in this case, 120 volts times 33.3 amps. So my transformed apparent power, which is just on this common winding, gives us around 4 kVA, depending on your decimal places, but it's close to 4 kVA. Now my S conducted, which would be my conducted apparent power, which comes from my series winding. We got to remember, it's actually still my common voltage, but now it's times my series current. Well, my common voltage is still 120, right? But now my series current is actually that 8.3 amps. Now what's cool is we get about 1 kVA there. So on this transformer, I'm getting 4 kVA from my transformed VA and 1 kVA from my conducted VA. So what's really neat is we've taken this mutual induction transformer, which was 4 kVA, right? We've converted it into an auto transformer, and now it's capable of 5 kVA. So we've actually increased the total VA rating of this entire transformer. And now we can prove that as well, right? If I take this series current of 8.3 amps flowing through my series winding, that's also going to be flowing here. We could also call that my secondary current, right? Well, if I take, S of my secondary would be voltage of my secondary times current of my secondary, well, 600 volts times 8.3 amps. What do we know? That gives us, again, just confirms that 5 kVA rating. So very, very cool. We could even go as far as to see it on the primary, right? Using Kirchhoff's current law, we knew 8.3 amps flowed up, 33.3 amps flowed down. Well, 8.3 plus 33.3, I don't even have that number, but that would give me my I primary. And I could multiply my I primary times 120 to, again, get that 5,000 VA rating. So that's the concept of taking a mutual induction transformer, converting it into an auto transformer. Again, it's not something we're likely going to see or do except for maybe an emergency or a very special, unique case. But the theory behind it is very cool. And what I like to emphasize here is really the windings themselves, the rating of the individual X winding and the rating of the individual H winding, those ratings do not change. The voltage rating stays the same and the current rating on those stays the same. So thanks so much for checking out this video. Like I said, check out my description below for some other Transformers videos, and have yourself a great day.